Alaikum warahmatullah. Welcome back for a new series of lecture. The topic is microfilters, where we're going to learn about the design and implementation of the microfilters. I have skipped actually one chapter. We're supposed to learn about chapter 7, where we learn about the microwave power divider, splitters, and directional couplers. But I want to come in coherence with the lab 5, so that's why I'm giving an early lecture on the filters first, and then later on I will cover chapter 7. So with this series of lectures, you will be able to do your lab 4 and finish and finalize all the labs. So that's why I am putting this filter design and implementation first. So let's start. Okay. For the starting, basically there are, we learned about it in many earlier classes, earlier courses also, that there are basic 4 type of filters. So in this lecture also, this is nothing different. So we will talk about 4 different type of filters, but the way of designing and the frequency and the consideration and understanding will be different than the others. So as we all know actually, that different basic, even though it's microwave or not, the basic filter types are actually 4 filter types. One is low pass filter, which this actually represents the low pass filter. This is called Bode plot, which is a filter response. I will discuss more elaborate in the next slide about this. So the low pass filter actually defines that all the low frequencies it will allow, and as the frequency goes high, it will start rejecting the frequencies, and it goes higher, it will not receive any more frequency. The high pass filter actually totally opposite of the low pass filter, where it will allow all the frequencies at a certain moment of the frequency higher than that one. So let's say this is here, it's a cutoff frequency, and then until it reaches to this point, it will not receive any frequencies, and then after that it will receive all the rest. So low pass filter will only allow the low frequencies, high frequency will be rejected. High pass high pass filter will only allow the high frequency signals, and all the low frequency signals will be rejected. Similarly, there is a combination of these 2 filters, like neither high or nor low. We can say like that it doesn't allow all the frequencies, but a certain group of frequencies. That's what we call band pass filter. That it will not allow all the low frequency, or it will not allow all the high frequency, but rather it will allow a certain band of frequencies that we will call band pass filter. And the last and foremost, but not the least, obviously, the band reject filter, which is opposite of the band pass filter, where it will allow all the low frequencies, all the high frequencies, except a certain band. Means this band, it will reject only, except this band, it will allow all the other frequencies. This type of plots called actually Bode plots, which is frequency versus amplitude. So frequency, this is frequency and this is versus amplitude. So as the frequency goes high, it is showing its characteristics. To know more elaborate about this filter responses, we go to the next slide. Looks a little bit messy, but that's necessary for us to understand the scenario of different filters responses. So let's talk about first the low pass filter. At low pass filter, it's basically a low pass filter is defined by its cutoff frequency. What is cutoff frequency? Cutoff frequency is a frequency that after that frequency, a designer considers that that filter will not receive any frequency further. It still receives, but due to the 3 dB point, 3 dB means a 50% of attenuation point, means let's say this is 0 dB, and then as the frequency goes high, because it's a low pass filter, so the low frequency will be received, and then it start decreasing, means here also it's receiving. At this point, it's receiving only half of the frequency that is coming, and then when it goes more, it's dying down. So here it's kind of like 0. So from here we consider that of a certain frequency of fc, we call it cutoff frequency. Here is defined what is its minus 3 dB frequency, or sometimes we call directly 3 dB. So at 3 dB, the defined definition of the cutoff frequency is tens. So only one frequency, cutoff frequency needed to define the whole low pass filter, since this is the end of our reception. So this is the amplitude versus frequency plot, and then we see this is 0 dB transmission, and then once it touches the cutoff frequency of 3 dB, actually when it touches the 3 dB, we consider this is the cutoff frequency. So after that, we consider there is no reception. One factor I tell you that this is the slope of the filter flank. We call it a crest factor. As sharp as this slope is, as better the filter is considered. So if this is like very sharp, ideally it's come like this in an ideal case. But since there is no ideal situation happens in the real world, so the filter actually gives a slope. So the slope, sharper the slope, better the filter response. However, to make this slope sharp, sometimes we have not a flat response. We sometimes have a ripple on top of this one. Later on, when we're going to design, we will learn about it. But I'm just giving you an introduction on this one. So this is how the low pass filter defined, where we have only one cutoff frequency and the filter definition is done. In a similar fashion, even though the high pass filter actually works exactly opposite of the low pass filter in terms of the frequency reception, but the high pass frequency and low pass frequency principle is the same. So here we learn that as it goes higher, it will reject the frequency. On the same scale, it works at the contrast, where the frequency goes higher, it starts receiving, and then the higher frequency will be received. Similarly, in the same way, at minus 3 dB, When it rises and we find it minus 3 dB, we find this is a cutoff frequency. So this definition of the high pass filter will be defined here at the cutoff frequency. So after that we have our all reception. So both of these high pass and low pass filters have one single cutoff frequency and the filter definition is done. Both of the cutoff frequency, actually in all the cutoff frequency, you can find it at 3 dB attenuation point. So this is the attenuation. Since this is amplitude, so that amplitude loss is 3 dB, means half of the amplitude is gone. So then we find the cutoff frequency. Now we move on to the band pass filter, which is a combination of the low pass and high pass. I already told you. So if you combine this one, so it becomes like this, where you can see it here. However, it have it have it have it have I have to interrupt now.